Here we have two equations, two nonlinear equations that we are trying to solve. For this problem, we take advantage of complex variable and rewrite this equation into complex form. Before doing that, we simplify these two equations. The first equation becomes x plus x over x squared plus y squared equal to 104 over 25. And the second equation would be y plus minus y over x squared plus y squared equal to 72 over 25. We then multiply the second equation by I, add these two equations to each other. So we have x plus x squared plus y squared, and then I times y minus y over x squared plus y squared equal to 104 over 25 and I 72 over 25. We rewrite this equation into a more appropriate form as x plus iy and then x over x squared plus y squared minus I times y x squared plus y squared equal to 104 over 25 and 72I over 25. We now assume that z is equal to x plus iy. And 1 over z is equal to 1 over x plus iy. Multiply both sides of this equation by x minus iy to write it into a standard form. And then this would be x minus iy over x squared plus y squared. So in the original equation, if this term is z, this term would be 1 over z. So rewriting the equation in terms of z, we have z plus 1 over z equal to 104 over 25 plus I 72 over 25. This would be a quadratic equation by multiplying both sides of the equation by z. So here we have z squared minus 104 plus 72i over 25 z plus 1 equal to 0. So we solve this equation. This would be b term, c is 1, and a is also 1. So z would be equal to minus b, which is minus and minus is plus, so is 104 72i over 25 plus or minus the square root of b squared 104 plus 72i over 25 squared minus 4ac divided by 2. At this point, we simplify this equation further, squaring the complex numbers and adding and subtracting to each other, taking the square root. We find that z1 and z2. So z is equal to 104 72i plus or minus 96 78i divided by 50. So from here we find two roots of our equation. z1 is equal to 200 plus 150i, with the plus sign we get z1 over 50, and this would be 4 plus 3i. So from here we find that x is equal to 4 and y is equal to 3. The other roots of this equation, z2 is equal to 8 minus 6i divided by 50. And this would be 4 over 25 minus 6 over 50, which is 3 over 25i. So for this case, we have x is equal to 4 over 25 and y is equal to minus 3 over 25. And these are the two solutions to these two nonlinear equations.